Welcome. We are Alain Perez, William Ochoa, and Félix Larrinaga. In this video, we will present the adapters for the Arrowhead framework constructed in NodeRED by Mondragon University. First, we will introduce NodeRED. Secondly, we will present the motivation, objectives, and architecture of the solution. Finally, we will present a demo on its application. NodeRED is a flow-based programming tool. It enables to describe an application's behavior as a network of black boxes, called nodes. Each node has a well-defined purpose. Data enters the node does something, and data comes out of the node. The network is responsible for the flow of data between the nodes. NodeRED is user-friendly. A web browser can be used to access the flow editor. Flows are shared as JSON files. NodeRED has a strong community behind, and it's very much IoT-oriented. NodeRED can be run in an embedded device. We can implement almost anything in NodeRED. In this example, we control and monitor the comfort values of a building, temperature and humidity, using several flows. To do that, we read and write into an OPC-UA server. These flows are connected to the previous ones, and in this case, we run operations on the values collected and present them in dashboards. We can also establish alerts by sending messages to a broker that can be seen in the button. Considering the success NodeRED is having in industry and IoT solutions, we decided to build Arrowhead adapters in NodeRED so we can develop Arrowhead compliant flows. This way, NodeRED flows will consume offer services using the Arrowhead framework. For that, we have created 6 nodes to interact with the Arrowhead core services: registry, orchestration, and authorization. We have included them in a NodeRED module. The module has been added to the NodeRED community for others to use. In this slide, you can see where you can access the development of a NodeRED that we have achieved. To better understand the functionality of this module and its nodes, we have prepared a demonstrator. The architecture is shown in this slide. On the one hand, we have deployed in Docker the Arrowhead framework with the core services. You can see it on top of the slide. We have also created NodeRED flows that offer Arrowhead compliant services for a legacy system based on OPC-UA as a provider. This can be seen on the left of the image. NodeRED and OPC-UA are embedded in a Raspberry Pi board. The board connects to a Lego device simulating a color sorting machine. On the customer side, we have created a NodeRED client using the orchestrator service that consumes the legacy system as a consumer through Arrowhead. You can see here. And we offer the consumer in a dashboard with buttons that can action the Lego machine. Here, we present the provider and consumer NodeRED data flows using the new Arrowhead nodes. The consumer is in the upper part of the screen. The provider is in the bottom part. You can see that they are in different machines. The Lego device is also shown in the image. On the provider side, we have 2 flows. The first flow, robot provider status, collects the status of the robot via OPC-UA and offers that status on an endpoint. The endpoint is a REST web service. This flow uses a token validator that checks with the Arrowhead core services the validity of the request. A subflow to register that service in the Arrowhead framework is also available. The second flow, robot provider actions, offers 3 endpoints to move the head of the machine left and right and to throw the piece. They use the token validator node. Service registry in the Arrowhead framework is also available for these endpoints. The Arrowhead registration node allows the selection of the Arrowhead host, port, and service. It also allows to specify the authentication method. In this case, we are using tokens. The node enables to indicate which is the provider system. We can also register the service name and path. In the Arrowhead token validator, we can indicate where the Arrowhead authorization service is available. We can now deploy the flow. This will register services in the Arrowhead framework. The services as REST endpoints are now available. On the consumer side, there are 4 subflows. Each subflow consumes one of the endpoints offered by the provider. Consequently, there is a subflow to move the head left, another to move it right, another to throw one piece, and one that gets the status. Each subflow uses the Arrowhead service discoverer to query the Arrowhead framework about a given service information, collecting the host, port, and path for that service. With that information, the flow builds the web service request and calls the remote service. We have included nodes in each subflow to access them through a user interface dashboard. You can see those on the left. We can select which is the Arrowhead orchestrator server, port, and path in the service discovery node. We can also establish the authentication method. In this node, we can indicate which is the Arrowhead consumer service. And finally, we can indicate which is the service endpoint we are looking for. Now we will connect to the user interface in NodeRED to operate the machine remotely. In the user interface, we can monitor the status of the machine. There are also 3 buttons to operate the machine. Let's move the head of the Lego to the right. Now, let's throw one piece. Let's move the head to the right and throw a piece. We can operate the machine remotely, as it can be seen in the video. We are always using the Arrowhead framework for all the calls. The module we have created is available in the NodeRED community. You can install it just accessing the palette and typing Arrowhead in the Install tab. In the video, it has been already installed. There is also documentation available on how to use the module in NodeRED. The module can be also installed as a NPM package. As you can see, the code is also available in GitHub. We hope you enjoyed the video and that our contribution to Arrowhead and NodeRED is useful for your developments. Thank you for your attention.